Okay, we finished until chapter 3. We are now skipping the chapter 4 and we jump directly to the chapter 5, where the chapter 5 is the grid connected PV system. Okay, the contents of this chapter is originally derived from the SEDA guideline book. Okay, and then this is the critical part on this subject. In this subject, we need to be very sure that all of us can understand it. Okay, because it's quite complicated, but not that very difficult. Because it cover, I think, almost half from the final exam, and also the overall assessment of the assignment is on the chapter 5. So this is critical part in this subject. Okay. As usual, today I'm not going to go very long because I have meeting actually right in parallel, so I need to be very fast. So we are going to the next chapter that we are waiting for, which is the grid connected PV system. Okay, we know already. Grid connected means on grid PV system that are connected to the electricity provider. In Peninsular Malaysia, we call that as TMB, Tenaga Nasional Berhad, and all the things that the wording comes about net energy metering, feed-in tariff is all about the grid connected PV system. Large scale solar is the grid connected. Okay, so this is the thing that need a regulation. That's why they need a authority to allow you to use this. You can't simply install in your home just because you know that kind of stuff. So it doesn't mean that you can easily install it because it's totally against the regulation. If you try to install the grid connected PV system without the proper license or permission from the SEDA and also from the purchaser, everything in the contract, the PPA. Okay, alright. Okay, first of all, we are going to the first part, which is the design criteria. Okay, the design criteria for the grid connected PV system. Uh, okay, first of all, I think I mentioned before the importance to do a site survey before the system is designed. Uh, yeah, of course, in the work of the engineer that designed the PV system in the company. So of course they're using the software they call PVC, something like that. So they're doing all the design. Uh, but one of the critical part in this is to use the site survey. Kejap saya ada call lah. Kejap. Kejap. Jadi kenapa yang ada kelas ni? Kenapa? Kenapa kau layak? Ada kelas dah. Okay, sorry for the interruption. Okay, site survey is required before the system is designed. First of all, determine the solar access for the site. Okay, solar access for the site. Determine whether any shading will occur and estimate its effect on the system. This any shading, it reflect to the solar pathfinder or the sun eye. The use of the sun eye tools, the equipment, or the solar pathfinder. Okay. In order to determine whether any shading will occur, whether any shadow will exist on the place that we are going to install. It's very critical to avoid any insufficient generated energy. Okay, so we have to make sure the all these things are in place so that there will be no shading in the place that we are going to install the PV system. estimate the solar resource at the site. I think most probably we can, of course, we can use the PVCs that provide us the solar radiation. I'm always saying about the PVCs because this software are generally used for almost all solar company uh, that do the design, that do the installation, design of the grid protected PV system. They are mostly using the PVCs, only the PVC software. I don't know other software, but it looks like they are commonly know. They are frequently use this kind of software as the basis for them for the design. Okay, they have the part that we can interpolate. We call it interpolate the what we call that, the overall irradiation on that specific place. Just put the GPS coordinates, then you're going to get that table. But still, that one in term of the satellite, the eye of the satellite or radar, uh, the most important thing is you to go there to make sure there will be no physical shadow that will merge in your place. Okay, that will appear in the place of your what we call it, the solar site that you are going to install. Okay, so estimate the solar resource at the site. So next, we're not covering in this part, but still these things are the basis. Determine the available area for the solar array. Okay, it's usually, of course, used for the installer. For the designer, usually we don't really go specific with this, but at least we know where is the plan, where is the place that you are going to install that. So determine the available area for the solar array, whether the roof is suitable for mounting the array or not. For example, maybe you cannot use the asbestos based roof. Asbestos, it's not proper. Maybe you can use zinc. Is it the shadow? Is it the roof is tilted or the planar roof? So you have to know, is it possible for you to mount the array? Is it really concrete or they just use the ceiling only, for example? Okay, so that the kind of things that you are going to know that when you go there, you're doing the site survey in that place that you're going to install. Okay, very important. Next, how the modules are mounted on the roof. If on the roof, then we should plan. Of course, we need to liaise with the installer. But at least you know the place that you're going to mount the roofs. Maybe okay, this one use zinc and planner. So what should we do? So that kind of thing, let you know. To be honest, I also doesn't know what is exactly this kind of work happen if you're not going, if you're not joining that company. We don't know. If we working together with the company, and then there's part of the installer, so they bring together the brother, and at the time we are going to discuss all what will we do on for the installation part. Okay, but I think at least you know they have the roof, they have the land, piece of land, something like that. You need to know that kind of things. And then determine components location to be installed. Okay, where the inverter will interconnect to the grid. Okay, where is the place for the inverter? What is the size of the inverter? So where should the cable will be pulled from the roof? In what route? So that kind of thing you need to know once you do the site survey. That's very clear lah. You know where to install that. So where the array junction box, inverter, meter, cabling route, how long? Like on the design, basically on the design, maybe you write 20 meters, but if you get to that building, maybe there's some reason like curvy angle, something like that, or there's some slab. So maybe you need to change the route of the cabling. So that's why it's very important to know the site survey. To go there, to know the situation, the real situation of the physical structure of the building, for example. If in the picture maybe okay and you just decide, then you can put how many meter, how many meters. But if you go there, oh, you need to do the another route, cable route, because there's a fan there, for example. There's the picture or something like that. There's a wall in the wall, so you cannot pass that shortest distance. So you need to do maybe you need to look hole around the room, for example, so there will be additional costing for the cable size, cable length, or maybe the additional use of the trunking, for example. So that's why it's very important to go there. Okay? Not only based on the paper or the design that you did on the software. Okay. Okay, so that inverter we have learned already which inverter is suitable for us. For example, if you choose to use the central, so you need to know the relevance of using it in central. But I would say that most cases, maybe we are going to the multi-stream type of inverter that have several channel. Okay, they have several channel, for example, so then can proceed with that. So it's very important lah. Very important to use the inverter. Even though they have string also in central, but recently trending they are using the multi-string type of the inverter, grid inverter. It's easier and efficient maybe in terms of cost and also the use. Dengar saya kan? Ke saya cakap seorang? Dengar kan?
Ada.
Alhamdulillah masih intact. Okay. Alright. But another thing is very important to consider. Okay, to consider when we are installing this kind of PV grid connected PV system. So things to consider when selecting an inverter. The peak rating of the PV array. Okay, the peak rating of the PV array. It's different. Like I mentioned in the solar power plant in Pekan near Turumpin. We call that as the size. Okay, the size is maybe around 41.1 blah 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 megawatt DC. Okay, megawatt DC is the part for the DC lah. Originally the peak rating of the PV array is the 41 point something megawatt DC. But the contract with the TNB is only 30 megawatt AC. So the total of power that is exported directly to the TNB as a contract. Okay, so the contract is about 30 megawatt AC. Okay, when we're talking about the solar farm 50 megawatt, it refers directly to the AC type, which is the total of power exported to the TNB is the rated power that are written in the solar farm in general. In their name, 100 megawatt mean 100 megawatt AC. Mostly lah. But in order to know how many DC, usually you need to refer to the contract lah. You need to see the contract or any information given by the owner. Then you're going to know what is the exact size of the PV array. So this is the PV array size lah. The original PV array size peak rating is the 41 point something, but the exported one to the electricity provider is 30 megawatts. Okay, so that's by considering the inverter. So that I told you later we're going to learn how to choose the best inverter for your system, for your design. Based on design, which inverter is suitable will be depend on the nominal power of the AC, not the nominal power for the DC. Okay, the target is to get the inverter that are suit with the nominal AC power, nominal output power, not for nominal DC power. For example, we have 15 kilowatt of inverter size. Okay, basically it refers to the nominal output power. It's the AC one, but you need to refer to the data sheet, and the data sheet we write in detail what is the nominal AC, what is the nominal DC. The things that we're going to refer is AC, but it's okay. After this we will learn detail. Okay, so that's the thing. So next is the whether all the solar module are the same plane, the same T angle and direction. Like I told you before, most recent inverter, they are equipped with the function of MPPT. All the inputs for each string is equipped with the MPPT function. What is the meaning of that? The inverter will always drive the power originated from the PV module on that string to the maximum. So that is very important for the MPPT function. The MPPT algorithm is equipped there. In other words, it will reflect, for example, if you go to the Gambang one, if I'm not mistaken, the 50 megawatt Gambang, just the LPT, beside the LPT, near the Gambang area, if you see it properly, you're going to see that all the modules, of course, they are connected in series, several strings, but they will follow the what we call contour, what we call it, the shape of the hill, okay. But maybe if you notice, there's several strings or the several sides of the PV modules are not facing in the same direction because of the structure, because of the shape of the hill. So maybe, for example, if this one is the, what we call it, maybe this one is the most optimum facing, but there's place where is the hill like this, so maybe they are not doing like this. Maybe they are doing in the different direction or straight, not the same direction like this. Maybe become like this, something like that. So maybe there's some situation where you cannot change the contour, you cannot change the shape of the heat. So even you change, also you cannot get the same direction as the optimum one. At the time, maybe they are facing slightly different to the majority group here, but it's okay. Since we have the MPPT function, it will help to boost the maximum power on that specific string to the maximum, okay, to the highest they can. So that's the function of the recent trending inverter. Okay. Alright. Okay. Then next part is the type of shading that occurs on the array. We have, actually the best one is to avoid any shading that may exist on your PV array surface in whatever condition, because if there's a shadow there, it will create the hotspot. One, you have the hotspot, you know already, we learned already. The hotspot will, what we call that, will degrade the output, okay, the output current of that specific module, which leads to the major decrease of that entire string current. So that's why we try, whatever condition, we try to avoid any shading, okay. There shouldn't be any shadow, okay. There shouldn't be any shadow that can appear as the shadow, as the blockage for your PV module. Okay. Next, capital cost of the different inverters, of course lah. Most cases we are referred, of course, first specification. Second factor, we are talking about the price. So that's the thing, capital cost of all the cost, total cost. It need to be estimated in total lah. Okay, in order to choose the best. But we are not covering on that level lah. We just covering is based on the rating of the PV array. And then next is the average annual energy yield. It's very, very super important. To know the average annual energy yield will be based on that. That you can use that software. They can estimate the value of the total irradiation for a year, which means total PSH for the year. For example, typical pace maybe becomes 1,700 hours per year. Some place maybe 1,500 something blah 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 per year. How can we calculate? Like I told you, in a day we get 4. In a year, then in a month you get 4 multiplied with 30. Then we got around 120 hours per month. That is, I mean, the minimum lah, 120 hours per month. So multiply with 1 year, that 1 year will lead you to maybe 1,440 hours per year. Maybe this is the worst case lah. 4 hours per day for the year is 1,440 hours of the PSH. Okay, so that is the value of PSH. But for average annual energy yield is in the megawatt hour lah, megawatt hour or the watt hour. Okay, how can we get the average energy yield? Then we are going to multiply with the P array. P array is the megawatt one. For example, if our system is 1 mega, then 1 mega multiply with this, then you calculate by yourself lah, like that lah. Okay, if the 1 mega, what is our size? If we are proceed with the 100 mega, so there will be the thousand of megawatt hours of expected annual energy yield. So that's how many hours that we get 1,000 Watt/meter of energy, okay, in a year. They call that as the annual energy yield. Boleh dengan saya ke? Alia, faham ke? Boleh kan? Layan je lah. Tak masuk calculation. We haven't come yet to the calculation part. So we just first in the theory part. Okay. Saya ada less than 20 minutes only. Okay, now we are going to the system sizing. Okay, there's 3 types. There's several criteria that can be considered in order to design grid-connected PV system. Okay. The first one, designed to fit on available roof area. So determine the total number of modules that can be mounted on the roof. It means that we are going to design based on the dedicated area given to us. So the first priority, for example, the first client say that we have 4 acres of the land that we want to maximize the number of modules in that piece of land. Please do the design for us. About the cost, we don't care because we are super rich. We don't have problem with that. The problem things is we want the biggest as you can design, the best size, the biggest size that can propose to us. Okay, we don't care about the cost. So the first criteria will be based on the roof area or the land area. Okay, for example, we have in UMP, for example, UMP Pekan, in faculty electric faculty. So we have several roof. It's quite challenging to install because it plays with the several roof. Then we need to do the cable also different if you want to connect series and so on. It's quite complicated. For example, the target is to fulfill all the roof or change all the roof from the roof metal deck, zinc, or the in Malay we call atap genting kan. We change all of that. We want to change with the PV module and we don't care about the cost, for example. So then the design will be based on the area or the land. Okay, the area of the roof or the land. So second criteria is designed to meet the budget. Okay, determine the PV area capacity that fits within the budget constraint. I think this is the most cases happen in anybody. We have 40,000 ringgit. So we just have this kind of budget. Please do the maximum. Of course, we need the maximum as we can within that 40,000. But if I have a good connection with certain people, VIP people, maybe I can get more. 1 million of budget. So at that 1 million of budget, please do the design for us. So that one will be based on the budget. Usually, the rate will be based on the per kilowatt peak. Means that, for example, 1 kilowatt peak of PV array costs you around 3,200 ringgit. Completed with the inverter, cable, and other module and so on. Okay, for the meter set Furthermore, I just giving you the rough typical value. I think now I'm not sure. Maybe they get less than that. Even now 4 kilowatt you can get 13,000 ringgit kan. For example, I just giving. So all the price will be in the per kilowatt peak lah, mostly. In most cases. Okay. So it's all about money. We have only 40,000. Then please propose the maximum size of the PV array for us. So that's the second criteria. Okay, the third one. Designed to meet yearly energy requirement. Determine the PV array capacity to meet the energy requirement. The third one is quite very strict because you need to fulfill when you say that yearly energy requirement, it refers to the megawatt hours. This value. So this megawatt hours is the contract. For example, 10 megawatt hour per year. We need to fulfill. So this is the PPA, power purchase agreement, that we signed already with the SEDA and also the client, the buyer. So we need to fulfill this number. This is the most item that are written in the contract. Okay, 10 megawatt hour per year. If we cannot achieve at the end of the year of the target of 10 megawatt hour, we will be penalized by the SADA authority. We need to pay, if I'm not mistaken, we need to pay some amount or something like that to the purchaser. I don't know the correct term for that. The client, I mean the electricity buyer, which is in this case is TNB, Tenaga Nasional Berhad. If I'm not mistaken, we will be penalized. We need to pay for penalty. Okay, if we can't achieve the 10 megawatt hours. So in order to achieve this 10 megawatt hour of energy yield or energy requirement, our design need to be done properly. Okay, use the appropriate modules, use the appropriate inverter and all the setup, okay, for the PV installation. Very critical.
Doktor,
Yes.
ada soalan. Kalau contoh untuk tahun tu, kemungkinan penurunan hujan tu melebihi daripada tahun-tahun sebelum ni dan dia kacau 10 megawatt tu macam mana?
If I'm not mistaken tu macam tu lah. Rasa kena penalty juga.
Even though sebab
tapi tak tahulah, maybe worst case tiba-tiba na'udzubillah min zalik, kita dilanda kan, ribut, na'udzubillah min zalik contoh tak boleh buat apa kan, hujung tahun tu habis kan. Mungkin dia ada negosiasi yang lain, saya tak pasti. Mungkin kalau dia menjejaskan the whole, tapi kalau kawasan kita je, saya rasa kalau tempat lain macam tak kena, dia mungkin ada sistem lain kan, dia macam kena penalty juga. Itu saya tak pasti lah, belum ada case lagi lah. Yang the case that I heard before, over generated. Okay, interesting thing is if over generated, this is the I talk with the one solar farm in one place. I not mention which place is it. Maybe their modules are perform very well, so they finish. They have achieved the target of the energy yield during early November, if I'm not mistaken. Early November they achieved already. They said at the time they are one of the pioneer of solar farm in Malaysia. That's why a lot of things they doesn't know. At the time, SEDA didn't give the very detailed guideline. So they refer from the overseas Europe, maybe, the calculation and everything. So and then they install everything. So at the end, I think early November they finish already. So what will happen on that? The contract is remain the contract. Whatever you exported after the target of 10 megawatt hour will not be paid by the electricity purchaser or the client lah. This is what happened. They will be based on the contract. If you do not achieve the contract, the target of the contract, you will be penalized. But if you exceed the value, they are not going to pay the extra. That is the contract return. So that's the what will happen on that solar farm. So they revise the contract and they succeed in revising the contract, so they can increase the target energy yield lah. But still they said, if I'm not mistaken, after the revision also early December, they finished also early. So at the time they said, it's okay lah, we just give free lah to the electricity client kan. So we just give free as the sadaqah, they said lah. Boleh Ashraf?
Boleh kata.
Saya tak ada experience lagi lah yang boleh reverse tak reverse kan, sebab hujan contoh tahun lepas kan banjir lagi kan.
Itu yang saya tanya.
Yang macam banjir kan, kalau air naik confirm dia shutdown kan. Mungkin tenggelam air kan. The case saya tak pasti macam mana negotiation. Mungkin ada heart to heart macam conversation kot, tak tahu lah. Mungkin ada negotiation yang kita tak tahu lah. Tapi by default itulah, if not achieve the target, you will be penalized. Okay, sikit lagi, 10 minutes only. Okay, until this level got. Okay, designed to fit on available roof area. Okay, the possible number of module that can fit on the roof is limited by the actual length and width of the module compared with the length and width of the available roof space. So, designed to fit on available roof area or the land area would be based the guideline, the benchmark will be based on the size of the module. Okay, the size of the module. So the modules could then be installed in an area either mounted lengthwise up or lengthwise across. It's okay. So this is what we call the lengthwise up, and this is the lengthwise across. These two arrangements are defined by the SEDA. So we are just following what they say. Okay. So a module has two fixed dimensions, length and width, and in general modules are in the rectangular shape, most cases. But it can become between these two arrangements. It looks funny because what is the difference? Just change the direction, but it's actually different. You can refer several modules just to change the orientation. Mostly we'll see that most cases they are using this lengthwise up. I would say that most cases in the roof that we see, mostly they are doing this. But there's some places that use the lengthwise across. Maybe the limitation of the area of the roof. Okay, like this. Designed to fit on available roof. So this is the example on lengthwise up. Okay, this is the example of lengthwise up. Okay, maybe the size of the roof just nice, so they can arrange with two strings. Okay, looks two strings there. But this one also, it looks two strings, but like I told you, it doesn't mean that it is 100% confirmed that it's all it's connected in parallel lah. It can become only one string like this. If the connection is like this, if the cable is connected like this, so means it's only one string. But in this case, we also say as the PV array, because we see more than one line. That's why we call PV array. Okay. Okay, the right one is the lengthwise across. So you across the module so that it can fit with this area. Maybe these cases just nice to put the 3x4 of the size of the modules. In this case also maybe several because of the roof. Okay, maybe the certain dedicated roof. That's why it can become both of it. Okay, between that either both of it. Alright. So what is the issue now? It's not the issue. It's the main point here. Designed to fit on available area. So how many modules can be fitted on allocated roof length or space? So this is the main important thing. How many modules? Let's say we decide this size of module. So we just want to put the maximum as we can on that roof. So the issue there is how many modules can be fitted on allocated roof length or space. So the solution like this. Okay. The width of roof vertical arrangement, length of roof horizontal arrangement. This kind of arrangement you just put, like that. So this solution will be based on the size of the module that we choose. So if we choose different watt, if you choose different brand, If you choose different side also, the size is not same. And differ to the brand also. Even in the same rated power, the size also different. Because I told you, each module has their own efficiency and as their own what we call as their own originality lah, based on the brand lah. So we cannot see that all are the same of the size. That's why it's very important how many module that we can mount on this area. Okay. The question is very super simple and I think very super straightforward. Okay. The first thing that you need to know, of course, is the size of your module. Module dimension. Like I told you, you can refer to the data sheet that we written how much is the length, how much is the width. Okay. We know these things, then we can calculate. The next thing is the roof dimension or the land dimension that we are going to install the PV modules. So that's why these two things must have. You have to make sure that you at least you know this kind of things. Okay, these two parameters is very important. If you don't know what is the size, it's not fitted with the first criteria lah, because we don't know your size and you don't know the size of the module. You know the size of the roof. We just install it. We don't care about size. That's not appropriate way lah. So we need to know what is the roof dimension and also the module dimension that we choose. Okay. So the first one is the length was up. Okay. Length was up means you arrange it up here towards the width of the roof. Okay, upwards, maybe upward like this. Okay, with the length was up, so the equation. Calculation for that vertical is upwards and up. We call it as an up. There's a new term, but it's okay. I use this and up with the roof over L of the modules because we arrange it the module upside way. I mean the normal way. We're standing up. That's why W roof over L module. Okay, for horizontal means across the roof, left to the right. So how many? So and up across and up across and up with the upper position, upward position, and then to the right, left to the right. Then is the L roof over width of the module because we stand around. So that's why it become like this. Okay, so the total of the module that you got, okay, will be based on the total and up multiply with and up across. However, sometimes you calculate with the points, decimals. One number 2.345 and this one 7.37. For example, we are not going to use the exact value of that. We need to round up or round down, something like that, to get the only solid number. Then we multiply solid number and the solid number. Not in the decimal. Okay, for the case of length was across number 2. Okay, the number 2, I call that as n across. With this direction, we call the n across. Upright. Okay, upwards. So, W roof over W module. So, this direction, this W module. And for the and across is L roof because it's now arranging as this level like this. So the length of the module. So L roof of L module, same thinking with this, only solid number. So this is only solid number, not the decimal. So you're going to get total up of numbers of module in total for that area. Okay, I give one example ni, but then we finish. Okay, we finish. For example, okay ke? Athir.
Ya, betul.
Okay? Boleh lagi?
Betul.
Ni senang je. Owi okay, Owi? Ada tak Owi dah?
Okay, betul.
Okay Boleh lagi Alright. Okay, let's say, like I told you, we need to know the module dimension. So you just take any data sheet that of the module that you choose. So you know that, okay, the L module is 665 millimeter, which is the 0.965 meter. And this one, the width of the module, you see that is 0.735 meter. most cases, the data sheet will write the length and the width of the module in a millimeter. Okay, millimeter. So you need to change it to the meter. Okay, alright. And the width of the roof is 3 meters and the length of the roof is 5 meters. So that in this one, because we are going to calculate upwards direction of the module. So W module, so this is the width of the module, width of the roof over length of the module. So width of the roof is 3 meters and the length of the module is 0.965 meters. Then you calculate it using your own calculator. Then you get 3.1088. Then after that, it is round down to 3. Okay. Wait 1 minute, wait 1 second. Okay, alright. Okay, that one is for the vertical part. What about the horizontal? Okay, horizontal, we know already L roof over width of the module. So ni L roof over width of the module. L roof 5 meters and you get 0.735 meter. Then you get the answer of 6.8027. And it is also written here as round down for both cases. Okay, if you see here, from 3.1088, it becomes 3, is round down to 3. And from 6.8 also, it is round down to 6. My question, why? Okay, my question, why it is round down, not round up? Syuhada Maisara. Syuhada Maisara. Ada Syahira Fazil. Tak. Syahira. Tak ada. Ayuh. Nurul Ain Izzati. Serius lah orang. Dengar saya ke? Kenapa suruh senyap ni?
Dengar betul.
Dengar. Orang yang tak reply. Izzat Imran.
Ya, doktor.
Kenapa di round down? Kenapa mesti round down? Kenapa tak round up?
Saya nak try boleh tak?
Maybe because we cannot break down the solar panel. Oh yo. That's why we round down. Okay lah, if you don't want Ganesh. Okay lah, let's say we cannot break down the module. So don't break it. Just round up lah. Then you round up, you can put the module, no need to break it.
So if we round up, it might not fit the roof. So maybe.
I mean, if we round up, it may not fit it to the roof. Okay. So the answer is correct. If we don't round up, for example, the number 6.8, which is the 7th one, it become like this. It comes out slightly. I mean, another 20%. Another 20%. 20% here is now coming out. Okay. So you cannot lah. You cannot. We must fit it exactly in the fitted in the roof. You cannot add additional another wood there and then put there. It's not relevant. So that's why we round down to make sure that all the modules are inside inside the area of the roof, not outside or slightly come out from the module. So Ganesh correct. That's the reason why we round down. So this is the maximum number of module that we can get, where 3 multiplied with 6, then we get 18. Remember, don't use the decimal number here. Decimal number here, put here and put here. No, nahi hai. Okay? Le. Okay? Boleh? Okay, sikit lagi. Sikit. Alamak, dah 253. Okay. So for the case of n across up is different now. N across up still width of the roof, but this time is width of the module. Then we get 3 over 0.735. Then we get 4.0816. Then it's round down to 4. For the horizontal part, with the left to the right, like this direction, and left to the right, 5 meter over the length of the modules. Then we get 5.1813, and then it is round down to become 5, and finally the final result is 20. See the difference? So the best configuration for this case is lengthwise across. It looks like, oh, it's different actually. It's not the same. If we change the orientation, it's already different. You can maximize more if we choose the correct arrangement or the orientation of the PV modules. Any question?
Doktor,
Ya.
soalan.
Yes.
Okay, let's say boleh ke gabung dua wise up dengan wise across?
Oh, we don't want that.
Let's say macam tengah-tengah roof tu ada tingkap, tapi tak muat untuk fit untuk apa ni wise up. Just untuk wise across memang
Okay.
muat.
If same numbers, okay. Same numbers module string tu. If several string, even buat WhatsApp pun, okay, adjust boleh masuk sama numbers, okay. The problem is each string tu different number kan. Even though I said that there's inverter that can play with that, but still to mix that tak berapa ni lah. Boleh lah cuba. Tapi most cases we are arranging in the same. As soon the number, I think if the number is still okay in one string, that one string I think recommended lah to use on the, if the number of module is the same, maybe because due to the roof, the roof size or the roof shape, so I think okay lah. But mostly we only in the one direction only lah. Okay. Boleh Ashraf?
Boleh doktor.
Pelik-pelik soalan kau. Nak sikit-sikit juga, lain-lain juga. Oh, okay. Soalan lain? Any other question?
No.
Oops. No question? Yo. No question lah. Let me ask. Fahim Nazmi.
Yes, sir.
Any question?
Not now, I think.
Not now, Okay, one more. Doctor, expansion and contraction occur in the material of solar panel. What do you mean by that? Expansion and contraction. What do you mean by that?
Like doctor, in summer the thing is spent
Again.
properties, material property expands
Material property expand.
because of heat.
Material property, I think not that. If in the frame, aluminum frame, the size of the modules, most cases they're not changing the shape of that. Most cases lah. You mean the shape or what? The shape or characteristic?
It's doctor, the photovoltaic, the material they made up of
Okay.
the silicon layer.
Yeah. Okay.
Does it expands in the summer?
And no, in most cases, I think the temperature that in Malaysia case, the highest temperature 75 degrees C. So that 75 degrees C of the set temperature will not change the physical structure of the modules. The inside also, the inner, but the characteristic will different. For example, voltage will drop. But that one we are going to cover after this. And in the next subtopic, we are telling there's different of when temperature is getting higher because of hotness, so it will degrade the performance of the voltage, of course. That one we're going to cover in the next subtopic in detail.
Okay, doctor.
Okay,
Thank you.
Any other question? Siti Nuraini.
Tak ada, sir.
Tak ada. Last call. Farhana.
Clear, sir.
Any question? Tak ada.
Tak ada.
Clear tu. Okay lah. If no question, then we finish here. See you on Wednesday. Alright. Thank you.